You're welcome. Episode number 4. We are still on the series on trapezium rule, the approximate evaluation of integrals. So if you watch the episode 1, 2, 3, by now you have armed yourself with a lot of weapon to attack these questions. So pause the video, attack it, and come back. Let's compare. Using the trapezium rule with 5 ordinates, we are to calculate the correct to 2 decimal places the approximate value of integral from 2 to 6 dx over x. Simply put, 1 over x dx. So let's see how we can put that into work. So our area we are looking for will be from 2 to 6 of 1 over x dx. So we are using 5 ordinates. Simply put, that is not the sub-interval. We need to know the width of the height, the width of the trapezium. So from here, so I say with 5 ordinate, the width height is going to be b over a, b minus a divided by n minus 1. Remember, while we are subtracting 1 from it, this is going to be the upper limit is 6 minus the lower limit is 2 divided by the number of stripe is going to be 5 minus 1. 5 minus 1 give us the number of stripes. 5 instead give us the interval, the ordinate. So this is going to be 4 divided by 4, which is what? 1. So the interval we are going to be adding to the lower limit to move to the upper limit is going to be 1, 1, 1. So let's generate a table and put that into practice. Okay, so the table is going to be in this form. Remember, we are beginning from the lower limit, which is 2. Then we add the length of the width of the trapezium to it. So plus 1, plus 1, plus 1, until we get to our upper limit. And the upper limit is 6. So here, we can also label here as y if you want to. And say that after you perform your division, the value is going to be the y value. No problem. But here it will be 1 over 2. 1 over 3. We are just going to be replacing the x by the values we have there on our calculator. So you put the 1 over 2, definitely that will be half. 6, 7, 3 decimal places. So these are the values we are getting. So why not y1, y2, y3, y4? So we can put our formula. By the trapezium rule, your area become half the height y0 plus y1, 1, 2, 3, 4. So y4 plus 2 times y1, y2, y3. We are picking them all. The first, the last, then twice the middle ones. So let's do the substitution. That will be half times age. And what is the age? The age is what? 1 times the first one, 0.5 times the last one, 0.167 plus 2 times this, 0.333 plus 0.25, 0.2. So now I think this is addition, We are adding these 3, multiply by what? 2. Then we multiply all of them by the half in front. So let's see how we can do that on the calculator. So the first addition here, if we add, we'll be having 0.667 plus, let's put 2 into bracket, 0.333 plus 0.25 plus 0.2, close the bracket, you have 1.56 as in there. So this becomes 0.5 times the value we have in the bracket, and that will be giving you 2.233. Multiply that by 0.5, and that will be giving us 1.1165. We have to do that correct to 2 decimal places. So our area will be 1.11, but this is more. So 12 square unit. So we are going to say that the area, the approximate area under this integral will be 1.12 square unit. I'm sure with these 4 episodes, you have the concept of what? Trapezoidal rule. Don't forget, we talk about its importance also being used in wind energy, in the calculation of the turbines, in order to convert the energy from the wind to that of electricity. Like, share, comment, and subscribe.